Today we're going to talk about density. When we think about the density of material, we're looking at the amount of matter an object has per unit volume. I sometimes think about how squished together the particles are. The more dense materials, keep in mind, are the ones that will sink if you put them into less dense ones. For instance, cold air will sink, hot air will rise. If you put glycerin or heavy syrup into water, it's going to sink to the bottom. Oil will float on top. So those are mostly applicable for things that are gases or liquids. As the temperature of material increases, the density tends to decrease because the particles spread further apart. So if they're less squashed together, they're not going to be as dense. This one is really important. It appears all the time on different kinds of tests, whether it's an SAT chemistry test or a biology one, whatever for STAR. If you cut an object into pieces, into smaller pieces, it doesn't change its density. Yes, it changes its mass. Yes, it changes its volume, but it doesn't change how squashed together the particles are. If it's a very dense substance, it's still going to be really dense when you cut it in half. So, now the question, would the density of an object be the same on the Earth and the Moon? Keep in mind, looking at our definition, that it's a mass per unit volume. Since mass doesn't change between here and the Moon, it would stay the same. Mass and volume, since mass and volume would both be the same on the Moon as they are here on Earth, the density would still be the same. Now we can calculate density by using this equation. Density equals mass over volume. I want you to be familiar with changing and solving for not only density, but for mass and solving for volume. And we're going to look at an example of each of those in our discussion today. Mass is in grams, as it says over here. Volume can be in either cubic centimeters or milliliters commonly. Now, when we get and deal with gases later, we'll often see that in grams per liter, but not now. Right now, it's going to be in grams per cubic centimeter, or excuse me, in cubic centimeters or in milliliters. So, density then, grams per cubic centimeter, grams per milliliter. Again, gases, we can see in grams per liter, but we're not going to deal with that at this point. Notice that 1 milliliter and 1 cubic centimeter and 1, as they say in the hospitals, cc, are all the same thing. A milliliter and a cubic centimeter are the same thing, and we're going to need to keep that in mind as we go through our discussion today. So let's look at our first example. A student finds a shiny piece of metal she thinks is aluminum. In the lab, she determines that the metal has a volume of 245 cubic centimeters and a mass of 612 grams. Is the metal aluminum? And it gives us the density. By the way, the periodic table that you have, the fold-out periodic table will give you the density of the substances, and you can Google them. Just make sure when you Google them, you get them in grams per milliliter or grams per cubic centimeter. Also, if you want to watch this video right here, that will give you a good, just a little bit of an overview on just kind of a cool density column that you can see them make. So the first thing we're going to do is what I've always asked you to do. We're going to circle what we're trying to find, and we're going to underline the pieces of information that we're given. Now, if we are just trying to decide whether the metal is aluminum or not, we're going to compare it to the density, then that's what we're going to be looking for. We're going to be looking for our density. Underlining the pieces of information we have, volume of 245 cubic centimeters and a mass of 612 grams. Those are the pieces of information we've been given. The first thing I'm always going to ask you to write down is the equation. Density equals capital D equals mass small m over volume capital V. Since we're solving for density in this case, we do not need to rearrange the equation, so we can leave it like this. And the rule is always we write the equation, we show the substitution, we give the answer. AP often gives points for the substitution part of equations and sometimes not for the answer, so we must show all of these parts. We want to make sure that grams for mass, cubic centimeters for our volume are the units that we've been given, or milliliters, either one for volume, and those are the units that we've been given, so we don't need to convert those. So now let's show the substitution part. Make sure everything that I am putting in either blue or red on this set of notes that you put on your worksheet, or you're going to lose points. If you don't show that original D equals M over V, you're going to lose points. If you don't show this middle step, you're going to lose points. So D is going to equal the mass value, and it told us the mass value was 612 grams, divided by the volume value, 245 cubic centimeters. So this tells us, since we have one number on top and one number on bottom, that we need to divide these two numbers. So dividing these two numbers, we get that D is equal to, and our interim value is going to be 2.49796. Our interim value. Remember that we must have a USS answer, units, sig figs, scientific notation. So let's get scientific notation first. Since the decimal is already in the correct position, what does that mean? It means that we can just tack on times 10 to the 0 on the end, because we need to move it 0 places. We don't have to move it anywhere. As far as our sig figs, if we look at our values in our problem, it looks like the 612 has 3 sig figs and the 245 has 3 sig figs. So it looks like we need 3 sig figs in our answer. So let's draw our sig fig line. That 7 tells us that we need to round up. So that 9 is going to round up to 10, which means that instead of having 2.49, we'll have 2.50 times 10 to the 0. And don't forget your units. Notice that nothing cancels or reduces to 1 here, so our units are actually going to be grams over centimeters cubed. Always check to see if that is a valid unit for what you're trying to find. And if you look up at your values up here, it does say that density can be in grams per cubic centimeter, so that is good. Now, our biggest problem here is that we'll often leave a question without really answering it. Did we answer this question? No, we didn't, because it didn't ask us for a number value. We need the number value because we've got to compare it, but it asked us if the metal was aluminum. So we look at the density of aluminum. It's 2.70. Is this substance pure aluminum? The answer is no, it's not. So make sure you've answered the question. Okay, let's look at the next example. The next example asks us, or tells us, that we have a piece of iron that has a mass of 2.25 kilograms. What is its volume? So we circle what we're trying to find, which is volume. We underline the piece of information we're given, which is kilograms. And, wow, we don't have enough information. What do we not have? We don't have a density. So how are you going to find that out? You're going to look it up on your periodic table, or you're going to Google it. And if you Google it, you see that it has a density for iron of 7.87 grams per cubic centimeter. 7.87 grams per cubic centimeter. So we have those pieces of information. So let's first of all write our equation. Our equation has to be written in the accepted form first, mass over volume. This time we're not solving for density, we're solving for volume. Now be careful, volume is on the bottom. We have to get volume first of all on top. The rule is get the unit on top first, then get the unit by itself. So the first thing we're going to do is to multiply both sides by V. That's going to reduce the side to 1 or cancel it. So right now we're left with V times D equals M, but we don't want to have D with V. We have to have volume by itself. So if we want volume by itself, now we're going to need to divide both sides by D. So if we divide both sides by D, it reduces to 1 on this side, or cancels. And look at what we're left with. We're left with the fact that V is equal to M over D. I must see the equation written solved for the variable that you're trying to solve for. You don't have to show all the blue work up there. I guess I could have written that in green, but you do need to not only show it in the original form, but also show it in the form solved for the variable that you're looking for. So V equals M over D. So the substitution part then, V is equal to the mass. The mass is 2.25 kilograms. Hopefully you notice that that has to be changed to grams. Must have it in grams for mass, and then either milliliters or cubic centimeters for our volume. So if we've got 2.25 kilograms and we want to change that to grams, remember how we do that. Kilo stands for 10 to the third. Gram has no prefix, so that's 10 to the 0. Our unit just got smaller by 3 places, so our number better get bigger by 3 places. Move that decimal 3 places bigger. So 2,250 for our gram value. The density we established was 7.87 grams per cubic centimeter. Our units cancel. Grams cancel. This says that we're going to divide these two numbers because one's on top of the other. And when we put that in our calculator, 2,250 divided by 7.87, we get a volume of 285.9. We need to put that into USS form, unit sig fig scientific notation. So let's change it to scientific notation first. So we need to move the decimal here. It's a number greater than 1, so we already know it's going to be times 10 to a positive something. So 2.859 times 10 to the positive something. And we have to move our decimal 2 places to get it in the correct position, times 10 to the second. So there's our numerical value. Now let's look at sig figs. Looks like the 2,250 has 3 sig figs. The 7.87 has 3 sig figs. So it looks like our answer needs 3 sig figs. So draw our sig fig line here. This 9 that we're focusing on tells us that we need to round up. So the answer to this question is going to be that the volume is equal to 2.86 times 10 to the second, and the units that we have left are centimeters cubed. So there's our answer. So finally, the last one, I'm just showing you an example of solving for each of the variables so that you can see the equations that we need. In the next one, it tells us that we're looking for mass, and this time it gives us that we have a lead sinker with a volume of 5.0 milliliters. I look up the density of lead, and the density of lead is 11.34 grams per cubic centimeter. and you might get 11.3 if you Google it or something like that. But look at your periodic table or Google that value and you can get the density. So there's your density. So those are the values we've been given. We know that the first thing we have to do is show our calculations, show our equations, so D equals M over V. And now we have to solve for mass, and we must show solving for that. We'll go ahead and do it in green this time because you don't have to show that, but you're solving for mass. So that means to get mass by itself, it's already on top. So volume's the hardest one to solve for. Once you get that one down, you can do any of these three variable equations. But in this case, we've already got mass on top, so all we need to do is get rid of volume. And we can do that by multiplying both sides by V. That's going to reduce this to 1 or cancel it over here. I always like my variable on the left, so I'm just going to flip-flop those values and say that M is equal to V times D. There's my equation. The substitution for this says that mass is equal to the volume, which is 5.0 milliliters, times the density, which is 11.34 grams per cubic centimeter. Now, notice what can happen with our units. If it helps you, you can put these in parentheses if it helps you see what you need to do with these. Why can I do this? Why can I cancel or reduce to 1 my milliliter and centimeter value? Well, look back up at the top of the notes and see what we know about milliliters and cubic centimeters. They're the same thing. So since they are the same thing, they are equal to the same value, they can be canceled or reduced to 1. So I'm left with grams, which is a valid unit for mass. And when I multiply these two numbers together, because they're side by side, multiplying these two numbers together, I get that M is equal to 56.75. Putting that in USS form, units, sig figs, and scientific notation, let's do scientific notation first, which means I need to move the decimal to here. It's a number greater than 1 to begin with, so I know it needs to be times 10 to some positive number. I know that it needs to be 5.675 when I move that decimal to the correct position, and it looks like I needed to move it one place to get it in the correct position. So 5.675 times 10 to the first. Now I needed the correct number of sig figs. It looks like the 5.0 has 2 sig figs. The 11.34 has 4 sig figs. So my answer needs the least, which is 2. So draw my sig fig line after 2 sig figs. The 7 says I need to round up that 6. So my answer becomes 5.7 times 10 to the first. And we circled grams up here, so there's my unit. And there's my answer.